this video, we're going to talk about horizontal asymptotes of rational functions. Horizontal asymptote occurs when the degree of the numerator is less than or equal to the degree of the denominator. There is no horizontal asymptote when the degree of the numerator is greater than the degree of the denominator. To help us determine the degree of the numerator and denominator, and to help us find these horizontal asymptotes, we would usually like to write the numerator and denominator in descending order of exponents before we begin this process, if they are not already written that way. So let's go ahead and look at number 23. H of x is equal to 6x minus 8 over x minus 3. There's an invisible 1 there that I'm going to need. Because the degree of the numerator and denominator are the same, the rule tells us that our horizontal asymptote is going to be equal to y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. It's going to be y equals 6. For number 24, g of x equals x squared plus, that looks like a 1x, not sure why there's a 1 there, minus 7 over x minus 7. Degree of the numerator is greater than the degree of the denominator, so there's no horizontal asymptote here. In 25, f of x is equal to 6x squared plus 9 over 6x squared minus 9. Degree of the numerator and denominator are the same, so the horizontal asymptote is at 6 over 6, which is 1. For 26, h of x is equal to 6x squared minus 7x minus 8 over 8x squared minus 9x plus 4. Degree of the numerator and denominator are the same, so y is equal to 6 over 8. We're going to reduce that fraction because both numerator and denominator are divisible by 2, so y is equal to 3 over 4. And number 27, degree of the numerator and is greater than the degree of the denominator, so there's going to be no horizontal asymptote for number 27. Okay. Let's move on to 28. Degree of the denominator is greater than the degree of the numerator, so there's automatically a horizontal asymptote at y equals 0. Not sure why that's not writing. Let's go ahead and look at number 29. That's why I wasn't writing. Let's just make some notes here for you. There we go. The degree of the top in number 29 is 2. The degree of the bottom is 3, because the degree of the denominator is greater than the degree of the numerator. we're going to have a horizontal asymptote at y equals 0. Degree of the numerator and denominator in 30 are both 2. Y equals -3 over 1 is y equals -3. Watch out on number 31 because it's not written in descending order of exponents right away. X squared minus 3. And then we have a negative x to the 4th plus 9x there. In the denominator, when we write it in descending order of exponents, the degree of the denominator is greater than the degree of the numerator. So we have a horizontal asymptote at y equals 0. Let's make sure 32 is written in descending order of exponents before we make a decision on it. Like so. Degree of the numerator is still greater than the degree of the denominator, so there's no horizontal asymptote here. And then in number 33, degree of the numerator and denominator are the same. Both 2. -1 divided by 1 is going to give us a horizontal asymptote at y equals -1. That's it for this section. Next time we'll come back and talk about oblique asymptotes, and we'll use long division of polynomials to help us with that.